All right, hello everybody. This is Mr. Carlson. I want to make a quick video to show you how to do one or two problems that I haven't shown you how to do yet in Chapter 3. And I'm going to show you how to do this in class tomorrow, but maybe this video will be helpful if you need a refresher over the weekend. So I'm going to be looking at a quiz from 3.2, Measures of Variation. I'm going to do the coefficient of variation one. It'll also show you how to do this one as well. I'll roll that in. So I'm going to click on practice, and we're going to do this question of systolic versus diastolic, and we're going to calculate the coefficient of variation. And the coefficient of variation, as a reminder, is a way to compare two groups. And specifically, it's comparing how dispersed their values are. It's the best way to compare two groups to see which one has more dispersed members or which one has people who are all centralized with very similar values. So what we want to do is, if you have Microsoft Excel, that's the thing to use in my opinion, because it's just so easy to use Microsoft Excel. However, I know a lot of you are doing your homework on Chromebooks, and so I'm going to show you how to do this on a Chromebook today. So I recommend what you do is you click Copy to Clipboard for your data, and you can see that it's all highlighted, all the data, and so I'm going to hit Control C on my keyboard. I'm going to hold down the Control button and hit C to copy. Okay, now what we want to do is we want to come over here and go to docs.google.com, and we're going to want to move over here to Sheets. So it says Sheets up here, and just click on blank to create a new one. Okay, so this is just docs.google.com. Go to Google Sheets, which has the green icon, and you can see that it looks like Microsoft Excel. So what I'm going to do is I'm just going to click the first cell, A1, and hit Control V, and you can see that it copied over my data, which is nice. I don't like having the titles be with the data, so I'm going to move them over. So I just highlighted those two, hit Control X, clicked over here, Control V to paste them, and I'm going to do the same thing with this data. Control X, put it here, Control V, and now my data is just alone in the two columns. Now this can be helpful if you're doing things like finding the median, because if you highlight the column, you can see this has this function button over here, and the function button has everything we could ever want, and we'll see that in a minute. One other thing you can do is click on data and click on sort range, and you can click sort range column A to Z, and notice that when I do that, and it put all the values in order. So that's nice. That's useful when you're finding the median and stuff like that. So that was under data, sort range, and then sort range by column. If you want to do the other column, you can just click column B, and same thing. So sort range, sort column B, A to Z. Now that's in order as well. We don't need to do that for what I'm going to show you, but I just wanted to show you that as well, because I know some of these have a lot of values and it's hard to find the median. Okay, what I'm now going to show you to do is how to use a formula. So there are several formulas in Microsoft Excel and Google Docs. Typically, the formulas are the same. So let's say we wanted to find the sum or the total of all the values in column A. The way we would do that is you can just write sum in all caps, open parenthesis, A colon A, and you can see that this column has just become yellow, because what this is going to say is find the sum or the total of all values in the A column. That's what A colon A means. And so when I hit enter, notice that it makes the number 1278, and so that's all of these numbers right here. So that's really nice. You want to be careful though, if you're going to use A colon A, you want to be careful that you don't accidentally have a stray number down here, because it will affect the difference if you have a number that's not part of your data. And so you saw how that changed it to 1282 when I added the 4 right there. So just be careful you don't have any stray values in your column. That's part of the reason why I moved these two out of the way, just so I know that this is the only numbers I'm looking at. So that's the sum formula. Another good formula is the average. If you do average A colon A, you get the average of all the values. So that's kind of nice. That's the mean. And so that's the average of all these values right here. And here is the next one, equals VAR. That's variance. Now there's two formulas for variance. One is S for sample and one is P for population. So in this class, most of the time we're working with samples, and so the formula you should use as your default formula is VAR period S. That's the sample variance. So if I do that for column A, it gives me the variance for column A, as you can see. That's the variance. And in class tomorrow, I'm going to show you how to calculate this by hand. It's a little bit complicated, but not too bad. Standard deviation, same thing. It's STDEV. And like with variance, we need to use the sample formula, not the population formula. So period S is what we want, and that will give you the standard deviation. So STDEV period S is standard deviation. So here we have the sum or the total. Here we have the average or the mean. Here we have the variance, and here we have the standard deviation. So that's a quick way to calculate it, a lot quicker than doing it by hand, I can promise you. And so let's see how we can use these numbers to do this problem. So the problem says find the coefficient of variation for the systolic measurements. So the formula is, the coefficient of variation. Let me make this a little bigger. Under view, you can increase the zoom a bit. That's a little better. Sorry about that. So the formula for coefficient of variation is equal to the mean divided by, I got it backwards. It's equal to the standard deviation divided by the mean times 100%. So that's the formula. So watch what I'm going to do. I'm going to type the equal sign. In all of these formulas, the first character needs to be an equals because that's what tells the thing that you're typing in a formula. So watch what I'm going to do. I'm just going to type equals the standard deviation, which is F7, divided by the mean, which is F5. So you can see the cells light up as I do that. I'm going to put that in parentheses just to be safe. So we have the standard deviation divided by the mean, and then times 100 to convert it to a percent. And so we get the answer 14.488%. The problem wants us to round to one decimal place, so that's going to be 14.5, hopefully. And there you go. So 14.5%, just like that. Let's go ahead and now calculate it for the diastolic measurements. And so there is a shortcut I could show you, but I'm going to delete all of this just to show you how to walk it through again. I'm just going to show you. So now we're doing the B column for diastolic. So I'm going to do equals average, B to B, B colon B. So there's our average. Now we want the standard deviation. So equals STDEV period S of B to B. And so just like that, I have the standard deviation and the average for column B, which was the diastolic. These formulas, by the way, are the same in Microsoft Excel if you want to use those formulas. So again, CV equals coefficient of the coefficient of variation is equal to the standard deviation divided by the mean times 100. So I'm going to do, keep careful on your cells. So equal E10 divided by E9, and I'll put that in parentheses to be safe, times 100. And so we get an answer of 17.1% if we round. That is how I expect you to calculate variance and standard deviation for your homework. And on the test, by the way. I will give you an assignment tomorrow to do it by hand just for practice. But most of the time, the reason we have these great programs is because the math takes a while to do sometimes, and that's why we have these calculators. So we can see that these two are pretty close to how dispersed they are, because remember, it's just standard deviation divided by mean. So the standard deviation here is 14.5% of the mean. The standard deviation here is 17.1% of the mean. So the diastolic is a little bit more dispersed than the systolic, but not by much, only by 3 percentage points. So the coefficients of the data set are within 5 percentage points of each other, because they're only about 3 apart. Therefore, the systolic measurements vary. Because the choice was within 5 or more than 5, I'm going to put within 5, and I'm going to say they're about the same as. That's probably what they're looking for. So let's see if that's right. Hooray. And so you get the idea, and you can do that for all of these. So just follow that same pattern. If you have any questions, please email me or click Ask My Instructor. I just showed you how to calculate variance. I showed you how to do standard deviation. I showed you how to type formulas into Google Chrome. Remember, without that equal sign, it's just letters. Okay, do you see that? It's just, and now it messed up my formula down here. So without the equal sign, it'll just be the letters. So if it's not working, it's probably because you forgot the equal sign. All right, thanks very much. I hope you found this helpful, and we'll see you in class tomorrow. Bye, everybody.